Welcome all again. Welcome to ASE Kalkitech webinar series. Myself Fahid. Today we are going into fourth session of 61850 webinar series. In this session we are going to drill down more detail into technical side of it, moving on to 2.0 standard. What are the additions that has come in 2.0 standard? Different security concept introduced in the standard. So that is the part of series 4 of 61850 ongoing webinar. So previous 3 sessions we had an introduction covering what is the communication requirement, what are the different scenarios in which 61850 is applicable and its aims, why it is future proof. Second session we gave an overview of the standard including multiple abstract communication service interface model including GOOSE, report and everything. And on the third session we dealt with the 61850 common tool, how to engineer, simulate and test 61850 different implementations and basic demo of the tools. In this session we keep this as the agenda, and first thing is 61850 going beyond substation, that is different standards beyond the substation. Then addition to overview, what are the features of addition to, then drill down to addition to concept, introduction of routable GOOSE in addition to and its communication layer when compared to GOOSE, when it is going beyond the substation, why the security requirement is there for the R-GOOSE, and how different certificate, key exchange and other mechanism to handle this R-GOOSE out. Different modes of testing of IEDs that is introduced in this standard, service tracking of GOOSE and other control block services introduced in the standard, concept of 61850-6 additional to configuration scenario extension, that is instantiated IED description and system exchange description. Then for the handling of network redundancy, PRP HSR, how the same is introduced. Then precision time protocol, how it is beneficial, and that is new addition to the addition to standard, and other changes of addition to of the standard. So this is the agenda item we are targeting today. This provides details of how 61850 is going beyond the substation requirement. As 61850 got popularized, this 61850 standard get extended to multiple levels going beyond the substation, and real-time data transfer going beyond the real-time data transfer. So if you see the details, the 61850 was first limited to the substation data, and 7-4 was the logical node associated with the substation, and then there were standards for inter-exchange between multiple substation that came as 90-1 of the 61850 standard. Then substation to control center that came as 90-2 of the standard. Then there were earlier control centers and other stations which were using 104, and the standard 61850 maps the 61850 models onto the 104 exchange mechanism, and how the CDCs can be directly mapped over 101 and 104, which is already used, that is dealt in 80-1. And then there is a power utility 1650 substation communication with the WAMS requirement, the data transfer from the synchro phases or PMUs to the control center for WAMS requirement, that has come as 90-5 in this R-GOOSE, routable GOOSE and routable sample value exchange concepts were came as part of 90-5. Then in order to take MV data from the network, 90-6 is underway for MV network data exchange. Then with the for the exchange of hydro DER power plants, 7-410 and 7-420 were made into place. So that is on the exchange of hydro and distributed energy resources. This is again using the MMS model of report and other stuff, but the logical nodes are additionally defined for hydro and DER. Then there is wind power plant extension 6140025 and the logical nodes extension as per that were introduced in wind standard 6140025. Then charging station underway, the 90-8 extension for the charging station for 61850 exchange standard for the charging station. So this is some of the standard that is going beyond substation. As 61850 get more and more popularized, this is going beyond the substation scenarios and getting popularized on other areas. Now moving on to edition 2, what are the changes? An overview of edition 2 is given in this slide. So introduction of routable GOOSE, as you are already aware, GOOSE was meant for transmission onto the Ethernet layer directly. So it is limited to within the substation. Now in the edition 2 as well as 61850 90-5 for PMU data exchange, R-GOOSE concept was introduced. And this routable GOOSE model is targeted of the GOOSE mapping onto the UDP layer. So this can be extended further beyond the router levels onto other substation and other scenarios. Then since it is going beyond the router scenario, security is very, very important in R-GOOSE, because there can be intrusions and other scenario which can corrupt the R-GOOSE or change the data. So improved security for R-GOOSE is introduced with respect to other standard. So that is we will be dealing with the details of that. Then improvement in testing of the devices with the addition of the service tracking and other functionality. We will go into an overview of that, how GOOSE simulation bit and other scenario can be used to improve the testing scenario. Then introduction of two more file scenario to 61850.6, that is instantiated IED description and system exchange description file were introduced. Then communication redundancy guidelines as per PRP and HSR were introduced in addition to for the network redundancy mechanism. Then further accurate protocol, and that through the Ethernet interface itself, that is a precision time protocol or IEEE 1588 is introduced. As GSSE, the generic substation status or state events, is no more as part of 61850 standard, because GOOSE got popularized and there were no one were using GSSE concept. So that is completely removed from the standard. Then addition of more logical node classes, 16 groups of logical nodes were introduced, and up to 159 logical nodes extended up to 16 groups were totally now available, and these logical nodes got extended maximum up to 159 in this standard. Addition of CDC, 11 more new CDCs were added to the standard. Then flexibility to define functional naming convention is introduced onto the standard. So these are some of the changes with respect to edition 2 of the standard. Key changes were highlighted in this slide. Moving on to what is the difference between GOOSE and R-GOOSE. So edition 61850 revision 2 standard and 61850 9D-5 dealt with the R-GOOSE scenario. So let's see. So if you want to transmit a GOOSE, these are two substations. So GOOSE 1, we want to send a GOOSE in the substation. It is going within the substation. GOOSE is going within the substation and it reaches router, then stop it there. It will not further go, and for the substation 2 also it is reaching up to the router and it is getting stopped there because it is completely mapped onto the Ethernet layers. It cannot pass the routers directly. So that is the concept of GOOSE. Now moving on to R-GOOSE, routable GOOSE scenario, in which R-GOOSE, as similar to GOOSE, it can send to within the substation LAN. So it gets transmitted within the substation LAN. You can see both R-GOOSE getting transmitted within the substation LAN and goes to the router. And even R-GOOSE, since it is mapped over UDP, it can even surpass the routers and go beyond the substation. So substation 1 to substation 2 or substation 1 to the control center, any scenario is possible. Similarly from substation 2 back to the substation 1. So this can be used for exchanging critical data between the substation, between substation and control center. The GOOSE information, sample value, everything can be done over the R-GOOSE, and it is modeled over mapped over the UDP layer, so it can pass the routers and go beyond the substation. That is the routable GOOSE that is getting introduced as part of edition 2 of the standard, and substandards like 61850 9D-5 uses this concept for sending the PMU data out from a substation to the control center, and in between exchange of the data between substation as per 9D-1 is also using the same scenario. Now moving on to GOOSE and R-GOOSE communication layers. So if you take GOOSE communication layer, this is on the GOOSE communication layer. So all the events, that is data set and data, is directly getting mapped onto the Ethernet layer for sending the same out in the GOOSE scenario. But for the R-GOOSE, it is mapped to UDP IP, that is UDP IP layer comes in between, and it is getting directly mapped onto the UDP layer. So this makes it routable over the routers. That is why this is defined in 9D-5 as routable GOOSE that can go beyond the routers. So this is getting mapped onto UDP IP. And on the sample value, it is directly getting mapped to the Ethernet, as you are already aware as per the 8-1, 61850 8-1. Now with the 9D-5, the PMU standard, the sample value is directly also getting mapped to UDP IP. So this can go through the UDP IP similar to R-GOOSE and extend beyond the routers onto the control center, or can be used between communication between the substations. So this is the communication layers of GOOSE and R-GOOSE different. So other things are intact. like client server model is there through the MMS and report using the TCP IP layer mapped over to the Ethernet. So this is on different communication layer of GOOSE and R-GOOSE details on the communication layer. Since it is this GOOSE is going, R-GOOSE is going beyond the substation and through the routers, through the private public network, it can go through the public network. So a security becomes essential for transmitting R-GOOSE over this layer. So let's see what are the secure mechanism that is defined. So R-GOOSE is defined in 90-5 and there is a TLS security defined as per 62351-3, and again there is a security extension for 61850 MMS and GOOSE scenario as per 62351-3. So this is altogether the R-GOOSE security management concept are defined in this standard, and I am putting it forward. So different layers of security is there. One is the authentication mechanism, and secure hash algorithm like SHA is used for the authentication and authorization scenario of the communication, and AES standard is used for encrypting the data between the publisher and subscriber. Encrypting the data, if that need to be done, the AES message encryption is used. Then message group verified by exchange of certificate. There are standards for the certificate exchange mechanism. So symbol certificate exchange protocol and other scenarios are used for the certificate exchange, and key management is done as per RFC 4107, and group domain of interpretation algorithms are used for key exchange scenario. So this is the general scenario that is used for each part, how R-GOOSE security can be imparted using different security mechanism is given in this slide. So AES for encryption, message group verified by the exchange of certificate, then key management done as per RFC 4107 is used for the key management. Now moving on to R-GOOSE certificate and key exchange scenario. There can be a control center in which we need to receive a GOOSE or from a substation, for example, and substation does the publish of the GOOSE. From the substation it goes through the WAN and receives it on to the control center. So this network is no longer trusted network, not like a LAN that is used in a substation. So that is why a security mechanism is essential. Now different scenario. The IGMP v3 uses the multicast management, and that is available in the routers as well as on the managed switches. For the IGMP v3 uses that for the multicast management. For the in this scenario UDP multicast management is used. Then GDOI, group domain of interpretation, is a protocol that is used for the key exchange scenario. So there will be a key distribution center located, and that will be that center will do the exchange of the symmetric and other keys with all the devices. So that protocol is known as a GDOI, group domain of interpretation, is the protocol used for exchanging the keys. Then for exchanging the certification, which is X509 based, all the mechanism like role based access and other communication scenarios are defined in the certificate as per X509, and a symbol certificate enrollment protocol SCEP is used for exchanging the certificate from certification authority to all the parties within the network is done using SCEP, symbol certificate enrollment protocol for downloading any certificate. Then validation of the certificate is checked with the online certificate status protocol. So continues at a regular interval whether the certificate is valid. That can be checked using OCSP protocol, and registration authority RA is used to validate this using the OCSP protocol. So these are main protocols and key parties that are involved in validating and exchanging the certificate keys and cross-checking whether my certificate is valid online. So now we move on to detailed scenario, how this is done on use case scenario. We are highlighting this. So first thing is, so we have a publisher which is located in the substation, and a subscriber that is located in the control center, then again a subscriber that is located in the substation itself. So first thing is issue the certificate X509 certificate request from all the devices, and that goes to the certification authority to issue all the certificate, and this is done using a simple certificate exchange enrollment protocol, a CEP request, all the device request for certification to the certification authority. That is the first step, and authority issues the certificate. Whatever all the details, role based access, everything is defined, and it is X509 based, and the certificate authority issues this certificate to all the parties in the network who are involved in all the communication, including multiple publishers, multiple subscribers, everything. And this certificate is even issued to key distribution center. So the selected, it can issue the keys to the selected parties depending upon the request and other scenario. Now everybody got the certificate. So all the device, including publisher and subscriber, has the X509 certificate, which says what are the permitted action I am able to do is described in this certificate. Now all the device verifies the certification keys with the key distribution center. So key distribution center provides keys to all the publisher and subscriber to decode the message which is sent from the publisher to the subscriber. So this request for the symmetric keys is done using a GDOI mechanism, and this keys request is issued by all the parties, including publisher and subscriber, to the key distribution center using GDOI request. That is group domain of interpretation is the protocol used for requesting for the keys. Now all the certificate is issued from the key distribution center to the devices. Keys were issued from the key distribution center to the all the devices using a GDOI response from the key distribution center. Now all the device can validate the certificate whether the date of registration, everything is right with the registration authority, and normally certification and registration authority will be in a single server. So OCSP, that is the online certificate status protocol, is used to validate the certificate whether it is up to date, and other scenarios gets validated. Then this response, OCSP response, after validating the certificate approval is given using the OCSP response. Now all the device validate the certificate are up to date, and with the registration authority, that is done using OCSP request and response. Now all the devices request for the symmetric keys also, and key distribution center sends back the symmetric keys based upon the GDOI request and response method, and these keys now will be used for the R-GOOSE to transmit the messages, and all the subscriber can use the symmetric keys for decoding the R-GOOSE message. So now the publisher send R-GOOSE on to both the scenario, and subscriber can decode that based upon the symmetric key. So this is the complete certification management scenario of involving all the parties in the network from the publisher to subscriber. So protocol used for this is SCEP, that is Symbol Certificate Exchange Protocol, for requesting and getting back the certificate. Keys and symmetric keys done by GDOI, Group Domain of Interpretations, for the key exchange scenario, and the validation of the certificate is checked by the Online Certificate Status Protocol, which is known as OCSP. Now moving on to different modes for testing, that is different modes introduced in the testing as per edition 2 of the standard. Consider an IED. So mode on, if there is a mode called on, in this mode the output is enabled and test is false, so that only the actual data can be transmitted over the output. Test cannot be performed if you put it onto mode on, that is testing is false and output is enabled. Then mode blocked. In this mode blocked scenario, output will be completely disabled and test is also false. In this scenario, no operation is permitted, including the actual forcing output and test. So this is second mode, mode blocked. Then mode test. In this scenario, output is enabled, so the direct output is enabled, and testing also is true. So whatever test condition we do, if it is enforcing output, the output will be activated in the test mode condition. Next scenario is mode test blocked, means output get blocked and test is true. This is one of the key scenario in which we can disable the output but do all the testing onto the device, so that the actual connection from the device to the breaker and other devices is not getting disrupted, because output we are disabling and it is in test mode. So we can do different simulation on GOOSE and other scenario to test the device out without impacting the actual output from the device. So this is test block, very important model. So in this scenario, the GOOSE simulation bit can be used to simulate the GOOSE and test different timing requirement of the system and other things at each point. What is the timing taken onto the device to operate on different levels by service tracking and without affecting the output. These all the things can be performed along with the service tracking capabilities that are introduced as part of standard. Now moving on to real use case scenario. So consider a service tracking of the control block service in a device in which we are operating actual outputs are here, and there is a CTL valve in which we will be issuing a operate command onto the CTL valve, and output is getting forced from this. So we issue a control command to the CTL valve, and we will be having using service tracking, we will be having at what time when this operation is received, the operate command received feedback goes out, so that using service tracking we can get this feedback operate received. Then operate OK, once the interlock checks are done, the operate OK is received. Once that is received, it is about to force the output. The operations are OK and it can force the output. So that is going back again from the service tracking element of OK. And we can also get the time at which this output OK is enabled from here, the timing at which the OK is getting cleared, that time also can be got back from the service tracking entities. If the mode is not blocked, this output will go out directly, forcing the output directly, and this output will set to, based upon this command, this output will get set. But if the mode is test block condition, output will be completely blocked, and we can issue the command and the output will not be forced to output. But using service tracking, we can get TOP OK, the timing at which the command is about to execute, but it will not be executed onto the actual contacts, but the time at which the contact is about to operate, that time we will be getting. And tracking this, how much time the device take to operate, we can test the same scenario out using the test and blocked mode, enabling the test and blocked mode of the device, and tracking the control service. Using the service tracking of the control service, we can track at what time the device will getting operated. The worst case timing scenarios can be projected out. So this is one of the key use case, in addition to with the service tracking and new mode introduced, everything can be possible with this. Now moving on to two other addition of the file, which is IED and SED. So earlier the scenario is IED capability description is taken from the global set. It has got a maximum superset of the device capabilities with the data elements and other things. Normally communication elements will not be defined in this, like data set, report control block, etc. will not be there. But using the IED configurator, we define all the full for the project. What are the using system configurator, we can define what are the data set and all other elements under the same, and loaded to the IED configurator, and the corresponding vendor IEDs. This is getting sent as a CID file, that is configured IED file. This is CID file, configured IED file to the IEDs. This is it. So once the IED is completely configured, we can use the same file, because it has got all the data set, report control block elements, and that is specific subset for the project is used here, so that we can instantiate from that to create the complete SED. So that in future project also, in other substation also, we can take. So that is an instantiated IED description file we can take and use to create an SED for other substation, other configuration. Rather than going with the global set, we can use the instantiated IED description and easily create an SED file out of that. This is point number one. So that is the IED. So the SED creation becomes pretty easy. That is, we are importing already configured one of the vendor IED model and reusing it for every other project created. That is one of the key. Then another is system exchange description. As we have come across, the data to be exchanged from a substation to control center, substation to substation, system exchange description file is needed, and that need to be loaded onto the other system, which gives a detail of what are the parameter that is exchanged from one substation to another or substation to control center. That is defined in system exchange description. So these two files are additionally introduced onto the standard. Now moving on to the network redundancy support. This standard introduced in addition to network redundancy support as per 62439-3, that is the PRP, parallel redundancy protocol, and HSR, that are the two protocols that is introduced as part of the for network redundancy. Moving on to parallel redundancy protocol, it is as per 62439-3 clause 4, and it is for the parallel data transmission, that is one device sends the data onto the two separate network in parallel, and those who are receiving first will be forwarded and the second one will be treated as duplicated and discarded. So when one network fails, it will be having the data from the other network, and it can be the complete bumbless redundancy is ensured in this case. So this is for the double star topology, suitable for large network, and you need to have two separate network at least to enable the parallel redundancy protocol. Now moving on to high availability seamless redundancy, HSR, it is for the ring network, and each device has two ports, and one message is getting forwarded through one port, it goes to another device, and it takes this and then forward it through the next port to the other device, and once it is the node who has originated the message identifies the message as got back, it stops over there and it will not recirculated it back to the network. So this is the HSR ring network. So this follows 62439 clause 3. Two-way data transmission, we are sending it out in and out onto the, so this is suited for the ring topology, and this is for the redundancy with low deployment cost, because this is only device is involved in this, no switches are not involved in this scenario, and each device can form a ring and have a complete redundancy. And you can have a mix and match of PRP as well as HSR coexist in a network. So this is one of the key scenario that is suggested for the network redundancy support in addition to. Now moving on to synchronization methodology. That's edition 1 standard defined a SNTP protocol, that is symbol network time protocol for synchronization. Here they have introduced another addition, IEEE 1588, which is a precision time protocol used for network based measurement of timing through the Ethernet layer itself. You can have the devices synchronized. One device will be master clock, and it can synchronize other device over the network directly if it support IEEE 1588. So completely Ethernet based link layer. There can be three methods of operation. One is UDP over IPv4, another is UDP over IPv6, and again the messages over Ethernet is also available, PTP messages over Ethernet. Any of this scenario with the device support, you can achieve the redundancy, and it can have an accuracy up to microsecond level is available. That is a speciality of IEEE 1588 protocol that is introduced as part of edition 2 standard. Now moving on to other changes. One flexibility earlier we had was IED based naming scenario, that is IED name, LD name, then LN, LD instance, LD prefix, then LN with the suffix. These things were permitted in the earlier use case scenario, but now that is changed on to a functional naming flexibility in which a substation name can be there, voltage level, bay, function, subfunction, then logical node. So either scenario can be introduced. So up to 129 characters is allowed for the naming convention in addition to standard. So this is one of the key introduction to uniquely identify the things from a functional perspective rather than on a communication perspective. This is one of the key elements. Then GSSE, as I mentioned, GSSE did not get popularized because GOOSE most of the cases handle the complete requirement of the substation. So this is completely removed from the standard and GOOSE is completely standardized. Then more CDCs and LNs were added onto the 3 more logical node groups were added, 68 additional logical nodes were added, and 11 new CDCs were added onto the system as part of addition to standard. So with this, we are coming to end of the 4th session of 61850 webinar series. In this, we have covered about what are the changes suggested in addition to with respect to R-GOOSE, with respect to different security concepts for R-GOOSE, then moving on to different scenarios of network redundancy, time synchronization, then testing methodologies. So all these things are covered with respect to addition to, including additional naming methodologies, additional logical nodes, additional CDCs available. So this we are coming to end of this session. Do contact us if you have any clarification needed. Thank you.